This video is talking about the slope of the tangent line and how it relates to the derivative. So in our activity that we did yesterday, we found that the slope of the tangent line at a given point, x equals c, is equal to the limit as x approaches c of f of x minus f of c all over x minus c. We're taking the rate of change between these two values, we're finding the slope between these two values, and we're taking the limit as x approaches c of those values. So we use another word to describe the slope of a tangent line at a point, and that word that we use to describe this is known as the derivative. This is a key concept in calculus. We'll spend a lot of time talking about that in AP Calculus this year. So because it's such an important concept, we give it its own notation. So we use f of x to talk about the original function. We use f prime of x to talk about the derivative function. So we could rewrite this part up here, and instead of saying slope of a tangent line at x equals c, we could say f prime of c equals the limit as x approaches c of f of x minus f of c all over x minus c. So this is a key formula that you want to know, a key equation you want to understand for calculus. So let's see how we could use this in an example. Let's say that I give you the function f of x equals x squared. We know that graph looks like a parabola, and we want to find the slope of the tangent line at c equals negative 2. So we can take our derivative function, our slope of a tangent line, and evaluate it at c equals negative 2. So I want to find the slope. I want to find the derivative of f prime of negative 2, which will equal the limit as x approaches negative 2, that's our c value, of f of x minus f of negative 2 over x minus negative 2. So then we're going to fill in the parts that we know. So the limit as x approaches negative 2, f of x is x squared minus f of negative 2. What's the value of x squared when x is negative 2? Well, that's 4 over x plus 2. Alright, so to continue evaluating this limit, we're going to take the limit as x approaches negative 2 of x plus 2 times x minus 2. We can factor that binomial. It's a difference of two squares. And then our x plus 2 terms will divide and give us 1. So we have the limit as x approaches negative 2 of x minus 2, and then we just use direct substitution to solve our limit, and we get negative 4. So it's always important to remember what these numbers, these values are representing. This negative 4 is representing the slope of the tangent line at c equals negative 2. So if we wanted to understand what this means on a graph, here we have our parabola, y equals x squared, and the green line is the tangent line. And notice at negative 2, 4, your tangent line is touching your graph at one place, and we can see that this line has a slope of 4. Down 4 over 1. So a slope of negative 4, excuse me. So what if I wanted to know the actual equation for this line? Well, in order to find the equation of a line, I not only need to know the slope, but I also need to know a point. So that lets me be able to use point slope form. You may have seen this in previous math classes. Point slope form is y minus y1 equals m times x minus x1. You need to know a point, x1, y1, and you need to know the slope. Well, we already know the slope for this problem is -4. And our x1, y1 values is the point that we want it to go through. Well, they told us that c is equal to -2, so that's going to be our x1 value. And if I find f of c, f of -2, that gives me 4. That's my y value. So you can always plug your x value into your original equation to get the y value for your point. So using this point, using the slope, I'm going to plug my numbers into the point slope formula. So I have y minus 4 equals -4 times x minus -2. So then I can take y minus 4, and that will equal -4 times x plus 2. Okay. The nice thing about point slope form is this is still an equation of a line. You can give this as your final answer even on the AP exam. If they ask you to put it in y-intercept form, you would just distribute the -4 to both terms in your parentheses and add 4 to both sides. So remember, this is the equation of the tangent line. Now, sometimes we are asked to find something called the equation of the normal line. So, the normal line is perpendicular to the tangent line. So once I know the slope of the tangent line, remember that comes from the derivative, I can take the opposite reciprocal slope, and that tells me the slope of the normal line. So the slope of my tangent line was equal to -4. The slope of my normal line is going to equal a positive 1/4. Remember to change the signs and flip the number. That's the reciprocal part. So my line is still going to go through this same point, -2, 4. So I'm going to use point slope form again to find the normal line. Y minus 4 equals, I'm going to use the slope for my normal line now, 1/4 times x minus -2. So I would have y minus 4 equals 1/4 times x plus 2. And so if we go back and look at a graph of this equation, this y minus 4 equals 1/4 x plus 2. This is the equation of our normal line. That will look like the orange line that is here. So I have my parabola, I have my tangent line that's in green intersecting my graph at one point, and then I have the normal line that is perpendicular to the tangent line. So those are three different things that you may be asked to find related to a derivative. You may be asked to find the slope, you may be asked to find the equation of the tangent line, and you may be asked to find the equation of the normal line. I'll include one more example in some notes that I will also upload to It's Learning that you can check for an additional example.